Hey, this is Mr. Ariel, and this is the AP Environmental Science Math Review 1 screencast. There's always some math-based problems in the AP exam, and so it's helpful to review how to work with some of the math concepts involved, so that you're ready for whatever comes your way on AP exam day. It's doubly important to practice these skills on paper because you don't get to use a calculator on the AP Environmental Science exam. Don't stress out about that because most of the problems aren't going to have you doing things like long division with really large numbers. The math-based problems are set up so that if you know the underlying math concepts and can set up the problem correctly, it's going to be relatively easy to do the math on paper without a calculator. So today we're going to review how to work with metric units and how to convert measurements using dimensional analysis. Most of the units you're going to see on the AP exam will be metric, and that's great because they're all based on factors of 10. I hope you learned this somewhere along the way, but if you haven't, it's time to brush up on a few things. The metric system has a base unit for every type of measurement. If we're talking about distance, meters are the base unit, and prefixes are applied to change the size of the unit. Now those prefixes are always the same, and they run from kilo at the top to milli at the bottom. You can remember the order of the units by keeping this sentence in mind. King Henry died by drinking chocolate milk. If you're given a measurement, let's say of 45 meters, you can use this diagram to figure out what the measurement is in other units. Like let's say we need to figure out how many millimeters that is. If we start here in the middle with the base unit of meters, millimeters would be 3 steps over to the right. And so that means we could take 45, where the decimal place is right there, and then we can put some zeros in to help keep track, and it's going to be 1, 2, 3 spaces to the right. And so that would be 45,000 millimeters. If we had the same starting base unit of 45 meters and we wanted to know how many kilometers that is, then the diagram will remind us that we need to go 3 steps to the left. And so 45 with its decimal place right there would be 1, 2, 3 steps. And so there would be a 0, and we would have 0.045 kilometers. And really that's the same thing as dividing by 1,000, and for the millimeters it was the same as multiplying by 1,000. But the little stair-step design can help you remember which units go where, and how much bigger or smaller they are than the base unit. Now there are a couple of prefixes that you're very likely to see, and some ones that you're extremely unlikely to see. You're probably not going to see hecta or deca on the AP Environmental Science test, and you're probably not going to see deci either. But centi, milli, the base unit, and kilo are all pretty much fair game. You stand a pretty good chance of seeing them. There's also one unit that's bigger than kilo, and it's going to be 1, 2, 3 steps above kilo. And that's going to be capital M, and it stands for mega. And if mega is 3 steps above kilo, then it means a million of the base unit. So put it another way, if we had a measurement that was 1 million meters, then that would be 1,000 kilometers, but it would be 1 megameter. And those are all the same distance, they just have 3 different units for their measurement. Now I'm thinking that you probably have this pretty well under control, and you might just need a little bit of practice with it. So I'm not going to do any more practice with this right here, right now. There are going to be some practice problems in a quiz on Moodle, and you can test out your metric conversion skills there. For now, I want to move on to a skill that I'm not sure you already have, and it can come in very handy on the AP exam. The skill is dimensional analysis, and it comes in handy when you need to convert a complex unit to another unit, and it's a little too hard to just move the decimal for a single conversion. It also solves the problem of knowing when to divide or multiply by your conversion factors. I'm sure you know that there are 60 minutes in an hour and 1,000 meters in a kilometer, but having to convert back and forth through lots of units at the same time, it can get confusing as to when you're going to multiply or when you're going to divide. As you probably know, the AP exam free response, where you have to show your work, that's pretty unforgiving on the math. So it pays off to know how to do these problems while showing your work and showing units. So let's try some practice problems, and I'll show you how this method works. First up, I can do a simple one-step conversion. Let's say that I want to convert 1.2 meters to millimeters. Now you might know the answer based on the previous method with the stair step, but when it's you against the test, sometimes having a guaranteed method to put on paper to work through can make you feel better that you've done the work correctly. And so the first step in this method is to write the measurement you're given over 1. And so I'll put 1.2 meters, draw a bar, and put 1. The next step is we're going to multiply by a conversion factor. And a conversion factor is a statement of equal value. And it's going to help us get from meters to millimeters. And so in this case, I know that 1 meter is equal to 1,000 millimeters. And so I need to write that conversion factor above and below the bar. It does matter where we put each part though. And we need to put the 1 meter on the bottom simply because we want it to be able to cancel the units we already have. And so if we put 1 meter on the bottom, then we're going to put 1,000 millimeters here. And then it's a hop, skip, and a jump through the math to say that this is going to be equal to 1,200 millimeters. And that would be the answer. Now notice that's the same thing as moving the decimal place 3 spaces to the right, like we did before. But this method really comes in handy when you have more complex conversions. So let me show you what I mean by that. Here's a different problem that's going to be a little bit more involved. And so where you can do the simple problems mentally and without a calculator, sometimes this method really helps when you get to more complex situations. And so let me show you what I mean. We have 45 kilometers per hour, and we're asked how many meters per second that would be. And so the first step is to always give the measurement and put it over 1. Well, I have 45 kilometers, and per hour means that we divide it by 1 hour. That's a hard step to remember for a lot of people, but if you were to put kilometers times hours up here, 45 kilometer hours doesn't really make any sense. And so really it's 45 kilometers per hour, which means we're dividing by hours. Now the next step is to put in some conversion factors, which are statements of equal value, and they help us get from the units we have to the units we want. And so I've got kilometers and I want to get to meters. And right now I know that 1 kilometer, I'll put it on the bottom so it can cancel, that's equal to 1,000 meters. And so meters are the unit I want in the answer, and so I'm done with the distance part. Now I've got hours and I want seconds. And so I've got to use conversions to get from hours over to seconds. So hours are going to go on top because I want to be able to cancel the one on the bottom. And I know that 1 hour is equal to 60 minutes. And so I'm a little bit closer to seconds, but minutes aren't seconds. And so I need to use another conversion. Well, minutes are going to go on the top simply because I have to be able to cancel. And 1 minute is the same thing as 60 seconds. And so if I look now, I have meters and I have seconds, and they're in the right places for meters per second. And so now all I really have to do is the math. And so I'm going to go ahead and multiply everything on the top, and that would be 45 times 1,000. And so that's pretty easy. It's 45,000 meters. And then everything on the bottom gets multiplied. And so 60 times 60 would be 3,600 seconds. I've got to do a little bit more math, and this is going to require some long division. No calculators allowed. And so I'm going to speed up the process just by canceling out some of these zeros. If you don't know how to do that in math, it'll work out the same way if you just divide 45,000 by 3,600. It's just going to be a little bit easier to do this way. And so now I'm just going to set up my division. I don't really know if this is how y'all do it in math anymore, but this is how I learned it back in the day. I got 450. Let me divide that by 36. And so 36 will go into 45, not there, but it'll go once. Into 45, so that's going to be 36. 45 minus 36 comes out to be 9. Bring down the 0, and 36 will go into 90 all of 2 times. And so that's going to be 36 times 2 is 72. So if I subtract those, I get 18. Bring down the 0. And I think 36 will go into 180. That will go 5 times. And when I do 36 times 5, that's 180. And so I get a remainder of 0. And my decimal was there. So there I have 12.5 as my answer. And so that's going to be 12.5 meters per second. And that would be the answer. Now, two things about the math. On the free response questions, you might be aware that sometimes you get a point for the correct answer. Always, always, always put a unit. And double check and make sure that it's the unit that was asked for in the question. You might do all the work and solve all of the math and come up with an answer, but if it's not in the right unit that the question asked for, you're not getting that point. And that's kind of silly, but it's also easy to double check and make sure you're getting it right. The second thing about the math on the AP Environmental Science test is this. Sometimes the problems look like they're going to be incredibly difficult, but what they're actually testing you on is the ability to understand the underlying concepts. And so a problem may start out looking like it's really difficult, but if it comes down to a situation that is a lot harder than just simple long division or something that you can do on paper in a minute or two, then it's probably an indication that you're setting up the problem incorrectly. Nothing on the AP Environmental Science test requires a calculator. And so oftentimes the math is set up to look like you need one, but when you actually get started setting it up and showing your work, it comes around pretty quickly that you can get the answer without a whole lot of work. Now, I'm not going to do any more practice problems in this video. You'll find a quiz on Moodle for trying out your skills on these concepts, and if you find that you need more help, let me know and I'll be happy to look at your work and help you figure out what's going on. For now, that's the end of this screencast. Thanks for watching.